Yes, sir. In this module, we will see the basic statistical terminologies used in the pharmaceutical development process. This slide summarizes the different terminologies which are generally used in the statistical applications of pharmaceutical development. Sample: a set of objects taken or selected either randomly or deliberately using a predefined criteria from the population which possesses certain characteristics that we want to study is known as sample. In a bioequivalent study, it is the human subjects included in the study on the basis of inclusion-exclusion criteria set in the study protocol. Population: a complete set of objects is called population. In most cases, this is set is very large and complete enumeration of all the values in population is impractical or impossible. The number of subjects in a statistical sample is called sample size. The sample size should be greater than the minimum. Number of subjects that are required to attain a desired power of statistical test. For example, if the desired power of test is 80% and the sample size required to attain this power is 18. So we must have to pick at least 18 subjects from the population to make inference from the sample to the population. Mean: the mean has different definitions depending on the context in preceding text. We will discuss here two types of means which is commonly used in the statistical applications. That is arithmetic mean and geometric mean. The arithmetic mean is sum of all values divided by the total number of values. It is also called average value. The geometrical mean is equal to the nth root of the product of all values. This can also be calculated by taking exponential of the arithmetic mean of log transformed values. Standard deviation. The standard deviation is a measure of dispersion from the mean value of dataset which shows how much variation exists from the mean value in both positive and negative direction. Larger standard deviation indicates that the data values are far from the mean, and conversely, smaller standard deviation shows that values are closer to the mean. Standard deviation is denoted by sigma. The standard deviation is calculated by taking the square root of mean square difference of each value from the mean. Variance. Variance is a measure of dispersion of data values from the mean value of data set. This is calculated by mean square differences of each value from the mean value. Standard deviation of the data is equal to square root of its variance. Inter and intra-subject variable. Inter means between subjects. Inter-subject effects means the effects between subjects. Intra means within subject. Intra-subject effects means the factors like period, sequence, or treatment affecting the test variable within the subject. To evaluate intra-subject variability, residual sum of squares of each parameter is divided by the degree of freedom. Significance. A significance level is used for statistical hypothesis tests performed on a dataset, and the level of significance generally is 5%. If the probability of the test is less than the significant level, we reject null hypothesis and accept the alternative path, which suggests that 5% level of significance, the results are significant. What is non-significant? The probability of the test is greater than the significant level. We accept our null hypothesis and reject the alternative hypothesis, which suggests that at a defined level of significance, the results are insignificant. ANOVA. ANOVA is an abbreviation of analysis of variance. This is a statistical analysis tool that separates the total variability found within a data set into two components, that is random and systematic factors. The random factors do not have any statistical influence on the given data set, while the systemic factors have the influence. The ANOVA F-test is applied to assess the significance of all components of the statistical model. The purpose of ANOVA in biostatistics for evaluation of set of bioequivalence data is same as that of the t-test, which is used in many purposes. The assessment of significance of sequence, period, and treatment on the model assumes that these effects are insignificant. Again, insignificant effects reveal the credibility of study design and management. T-statistics or t-test. Student t-distribution or t-test is the most commonly used test to check whether the two means are statistically different from each other. For example, when we give reference product and test product in a bioequivalence environment to a group of patients and check that the means of both test and reference product are statistically different, then we can use the t-test. The p-value reported by the t-test represents a probability of error in accepting our assumption or null hypothesis that both means are statistically different. F-statistics is used to check whether the two variances are statistically different from each other. The observed value of F-test is calculated by taking the ratio of one variance to the other variance. The more the ratio deviates from 1, the more the evidence for unequal variance. The p-value reported for F-test represents the probability of error in accepting our research hypothesis that both variants are statistically different. Confidence interval. The confidence interval gives us the estimated range being calculated from a given set of sample data such that we can claim that 90 or 95 or 99 or whatever percentage population values of unknown parameter will lie within the range. The wider is confidence interval, higher would be the uncertainty about the unknown parameter. What is normal distribution? If we plot the data against its frequency, the plot could be spread out on left or on right, or it can be all disorderly arranged, or in most cases it is spread around a central value with no bias towards left or right. Or it can be shaped like a bell, and this bell-shaped distribution having mean, median, and mode equals to mu and variance equals to sigma square. It is symmetric about the center and about 50% of values less than the mean and 50% of values greater than the mean. Power. The statistical power of test is probability of rejecting the research null hypothesis when the hypothesis is wrong. That is probability of not committing an error, that is type 2 error. The higher the power of test, the lesser the chances of occurring a type 2 error. In simple words, in a bioequivalence setup, in a 2 into crossover bioequivalence study, it implies to the power of not committing an error of declaring two products bioequivalent when the two are actually not bioequivalent. Null hypothesis. In a significance testing approach, null hypothesis is potentially rejected or disapproved on the basis of data that is significantly under its assumption. It should be chosen in such a way that it allows us to conclude whether the alternative hypothesis can either be accepted or stays undecided as it was before the test. Sequence, period, and treatment effects. The comparison of means of two treatments provides the basis of t-test and thus the p-value is established. The p-value of different elements of the model must be greater than 0.05 to establish non-significance at 5% level of probability. The effects of sequence, period, treatment, also known as fixed effects. In a bioequivalence study, these effects are assessed by calculating minimum variance of unbiased estimator, V value, 95% CI, T value and P value. In a authentic, well-designed and managed study, the sequence and period effects must be insignificant. Thank you.